Alright, there are a few concepts that I wanted to go over regarding solutions and concentrations. So for starters, we have two main types of concentrations. I won't go into detail here, but there's percent concentration. We can have percent by weight, we can have percent by volume, and we can have percent weight by volume. So if you watch these other lecture videos, you should be familiar with these already. And I would just give you one. Let's do percent volume by volume. So percent volume over volume. This is the volume of the solute, the stuff that gets dissolved, the solute, divided by the volume, and this is important, of the solution. Of the solution, and then times 100. So why I say this is important, the solution has two components, if you recall. Solution is the volume of the solute plus the volume of the solvent. So you have to be careful. There are times when they may tell you so much solute is dissolved in so much solvent. The volume of the solution is the sum of these two, and you have to be sure to use that volume for the volume of the solution. Same goes for weight by weight. It's the weight of the solute over the weight of the solution. So if you have, I don't know, 10 grams of sodium chloride dissolved in 55 grams of water, well, the total mass is not 55, it's 65. It's the solute plus solvent. All right. So that's concentrations by percent. So there's percent concentration. And then, of course, there's also molarity. Now, there are other units of concentration that we will not get into. If you look online elsewhere, you might find something called molality. Molality. This is, well, first off, molarity, this is given by the uppercase M. It must be uppercase, and the reason for that is there's a lowercase m. That's molality, also a unit of concentration. It is not something that we talk about in this course, so do not have to worry about it, except do not use a lowercase m. And it's not going to matter so much in the remainder of this course due to the virus, because everything is online and it's very clearly you're going to use uppercase versus lowercase. However, I should caution you that uppercase M is pointy on the top. That is not an uppercase M. That is a big lowercase m. So in further future chemistry courses, just make sure you make that distinction. This is not equal. In fact, we can make it a little bit smaller. It's not the size that matters, it is the case, right? So it's pointy on top, that's uppercase. This is a big lowercase. So don't use lowercase. That would be molality, which I won't talk about. All right, molarity is moles of solute per liter, again, of solution. Liter of solution. Oh, this is something else I should mention. It doesn't matter what units you use for volume, just so that you have volume over volume, so the volumes cancel. Doesn't matter which unit you have for weight, just so long as they're the same unit. So if it's grams of solute, it's grams of solvent. If it's kilograms of solute, it's kilograms of, I shouldn't say solute, solution. If it's tons of solute, it's tons of solution. So the units cancel. And that's why for percent, we have this kind of goofy little symbol here. Essentially, the units cancel out. So if it's typically what you'll see is milliliters or liters for volume, so it would be milliliters over milliliters times 100. The milliliters cancel, right? Or if it was weight by weight, it would be, we could use, I don't know, milligrams over milligrams times 100 milligrams of solute over milligrams of solution times 100. Again, the milligrams, the masses will cancel. Here, the units don't. So that's one thing to keep in mind. So molarity has, we use an uppercase M for the symbol, but molarity has units of moles per liter. It's always liters. It can't be it can't be milliliters. It can't be something other than moles. It's just moles per liter. That's it. All right, so that's a quick little background. Now the other thing that I wanted to talk about here, this is rather important, is the idea that when you have, well, let's use the dilution equation. So dilution equation, this should be familiar to you. Again, I won't go into the details. The dilution equation is similar to Boyle's law, if you remember from the ideal gas law. It's C1 V1 equals C2 V2. So what you'll notice if in a dilution, right? In a dilution, we're starting off with a certain set of conditions. So this is state 1, concentration and volume. In a dilution, the concentration goes down, right? So what does that mean? That means C2 will be less than C1. C1 is larger than C2. Its concentration goes down. Well, if the concentration is going down, right? If the concentration is going down, that means the volume has to go up. So when you multiply these two together, they equal. So if the concentration is going down in this is a dilution, then volume must go up. All right, so volume increases, so that means C2 is greater than C1. All right, so I just want to point out that fact. And the other thing to think about then is, I'll just write it down here real quick. Concentration changes, volume changes, but the amount of solute does not. So whether you're talking about molarity, solute is moles. If you're talking about percent by volume, the solute is milliliters or liters or cups or gallons, doesn't matter. If you're talking about per weight, percent by weight, it would be grams or kilograms, milligrams, pounds, doesn't matter. So concentration goes down in dilution, volume goes up, and the amount of solute, is constant. Okay, so I'm going to just pick molarity here and kind of show you what's going on. So we have C1 V1. If it's molarity, right, then the concentration is moles per liter. You don't have to do it this way, but it works out easier if you do it this way. If we multiply, so this is C1, right? This is C1. If we multiply that by volume, say volume in liters, that would be V1. C2 and V2 will use yellow. Moles per liter, that's C2. And if I multiply that by V2, right, volume in liters. So notice what happens here if you just look at the dimensional analysis. The liters cancel, don't they? Right, so liters cancel, and you're left with moles on the left-hand side. Remember, this is C1 V1. This is where we started off with. And if you look at the right-hand side, it's moles per liter, C2, times the volume after you've diluted it right now. So you have this new solution. It has a larger volume. Concentration went down, volume went up. But if you multiply volume times the concentration, the liters cancel, and you end up with moles. Whoops, I want to use yellow for that. So you end up with moles. Right? So the moles that you started off with is the same as the moles you ended up with. That's what I'm saying here. The amount of solute is constant. It doesn't change. You're not adding or taking away any solute. The amount of solute stays constant. The other thing is if you multiply, and this is true for, it doesn't matter if it's molarity or percent, if you multiply the concentration times the volume, it's really easy here with molarity, but concentration times volume will always give you the amount of solute in solution. Right? So let's just write this down. Concentration of a solution times the volume of that solution will always give you the amount of solute. Another very important equation. So let me clear this off and we'll go elaborate. Okay, so we have, let me just put it here, percent weight by weight, mass of solute over mass of solution times 100. We have molarity, that's moles of solute per liter of solution. And then we have what else? We have the dilution equation, C1V1 equals C2V2. There's a bunch of different equations here you need to know. And there's three flavors of percent, right? Percent by weight, percent by volume, percent weight by volume. There's molarity, there's the dilution equation. The fourth one that I want you to know is the amount of solute the stuff that's dissolved in the solution, is equal to the concentration times the volume, as I just showed you with molarity. So let's do the same thing, but let's do that now with say percent. So, and actually I'll write a question, the type of question you might see in a homework or a test. Okay, so let's say 450 milliliters of a I don't know, 18.5% let's say volume by volume solution of, I don't know, let's say alcohol contains how many milliliters, or they could say how much alcohol or what volume of alcohol, but I'm going to say how many milliliters of alcohol. So what we're looking for here is the milliliters of alcohol. That's the stuff that's dissolved, right? Solution of alcohol. So we're going to use equation number 4 here, right? With percent, it's a little bit odd. Now I'm going to actually maybe I'll put it over here on the side. If you think of it this way, if we'll make it easier for you. Let's say you have 50% solution. It doesn't matter if it's by weight or whatever. What does 50% mean? Well, 50% means it's like a 50-50 solution, or if you wish, half and half, right? So what does that mean? That means it's 50% solute and 50% solvent. I'm going to run out of room there, but solvent. Okay. So half and half, think about what half and half means. Half and half. Half, we don't use fractions like that. We use decimals. Half is 0.5, right? So it's 0.5 and 0.5. Now it might not seem that way right away, but all we're doing is saying, okay, well, 50%, think about what 50% means. 50%, I'll write it out here, is 50 per cent. Cent, what does cent mean? Well, there's 100 centimeters in a meter, there's 100 cents in a dollar, there's 100 years in a century. So this cent means 100. It's 50 per 100. That's why in all these percent calculations we multiply by 100. The decimal equivalent of 50%, what is this? This is actually 50 per 100. What is 50 per 100? Well, that's 1/2, right? We're not going to write 1/2. We're going to write 0.5. We want to write 0.50, right? So it's, you can see the 50 there clearly. So with percent concentrations, 18.5% equals 18.5% per 100, which is 0.185. So just as with 50% we had to divide by 100, we have to divide by 100 here, and that's because of this term here. I won't go through the algebra, but essentially, I mean, if you wanted to solve for mass or the amount of solute, you want to get rid of the 100, you want to get rid of the mass of the solution, so you have to divide each side by 100, right? So that's where that comes from. So with percent concentrations, be careful. You can't multiply by 18.5, you have to multiply by the decimal equivalent. So again, we're using equation 4. The concentration isn't 18.5, it's 18.5 per 100, or 0.185. So we have the concentration. What's the concentration? It's 0.185. That's 18.5 per 100, 18.5%. That's the concentration times 450. This will give us the amount of solute. Let me get my calculator out real quick. 0.185 times 450. I get 83.25. 83.25. And notice this is 450 milliliters. Oh, darn it. 450 milliliters, right? The only units we have here are milliliters. Remember I said the units cancel in these percentages. So this is a label. It's not really a unit at all. So it's milliliters times 0.185. So it's 83.25 milliliters. These are the only units that we're going to have. So if it was percent by mass, fine, it would be grams or kilograms or something. But we're doing percent by volume, so it's milliliters. All right, sig figs, there's 3 here, so 1, 2, 3. I'm going to round off to 83.3 milliliters of alcohol is in 450 milliliters of this 18.5% solution. So if you think about it, you know, here's our solution. It's 450 milliliters total volume. The alcohol is, let's see, if this is 450, this is 225, 1.125, so maybe right about here. That's this much alcohol. 83.3 milliliters of alcohol, and what's the remaining? So if this is dissolved in water, which, you know, most of your solutions are going to have water as a solvent. It's the universal solvent. So the water here is the remaining, what, 366.7. Is that right? Yeah, 366.7 milliliters of water. So the new thing here, right, which they didn't really talk about, is this equation. It's very helpful for finding out how much solute is in a solution.